SVM algorithm can be used for face detection, image classification, text categorization. Now we will see types of SVM. SVM can be two types. One is linear SVM, another is non-linear SVM. For linear SVM, linear SVM is used for linearly separable data, which means if a dataset can be classified into two classes by using a single straight line, then such data is termed as linearly separable data, and a classifier is used to called as linear SVM classifier. Non-linear SVM, for non-linear SVM is used for non-linearly separated data, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used is as non-linear SVM classifier. Now we will see hyperlane and support vector. Hyperlane, there can be multiple lines decision boundaries to segregate the classes in n-dimensional space, but we need to find out the best decision boundary that helps to classify the data points. This best boundary is known as hyperplane of SVM. The dimension of hyperplane depends on the features present in the dataset, which means if there are two features as shown in the image, then hyperlane will be straight line. And if there are three features, then hyperlane will be two-dimensional plane. We always create a hyperplane that has a maximum margin, which means maximum distance between the data points. Now support vector side, data points are vectors that are closest to the hyperplane and which affect the position of the hyperplane are termed as support vector. Since these vectors support the hyperplane, it's called support vector.